PCWI Porosity Holiday Detectors. The instruments and support you need for your industry. High and low voltage testing of coatings. Myths and misconceptions. PCWI manufactures a vast range of brushware to suit high voltage porosity detectors and wet sponge units, low voltage testers. These are the three units we have: a wet sponge unit, a pulse DC, and a DC, which is a direct current and a constant current unit. The wet sponge unit is a low voltage tester mainly used for thin films. Can a wet sponge test give a porosity free coating? No, it cannot. It would only find pinholes through to and exposing the substrate. A low voltage wet sponge test would only find flaw number 1. That would also be dependent on the floor's diameter, coating thickness, and the floor's capability of being wetted out. All the other flaws that a wet sponge unit will not find. If you're satisfied with that as a result, then the low voltage wet sponge test may be suitable for your project. That is, providing you can get back to revisit a few years later to evaluate the coating system to carry out recoating and repairs. This test does not guarantee a flaw-free coating system. Depends on what you call a flaw. For years now they said you cannot test thin films with high voltage porosity holiday detectors. Yes, you can. Electronics have changed dramatically over time. Although, do not use a high voltage pulse detector. I don't recommend the use of those on thin films. To use the latest DC, direct current, constant current, high voltage units, test films down as low in thickness as you want. The high voltage detectors. Can a stationary probe on the surface cause burn through of the coating, creating flaws and pinholes? During testing, a stationary probe left long term on the coating surface has no detrimental effect on the coating whatsoever. Can subsequent multiple passes of high voltage when testing weaken the coating, cause burn through, creating pinholes? Multiple passes and retesting with high voltage has no weakening effect on the coating. Finding new flaws, pinholes, when testing repairs in previously tested areas. It does happen, and there can be many reasons for this. For a starter, let's look at some of this. Heavily corroded substrates. Only test with a brass wire probe. These fall into the holes. The carbonised rubber strip probes will not fall into the indentations like a brass strip wire probe will. This should have been the probe that was used here, not a little fan brush. As you can see, there's going to be a terrible amount of missed areas, and on retesting you'd most likely find all the spots not covered before. Heavily corroded substrates and rough coatings use overlapping passes as in A and B. This area of porosity that's shown as number 4 is a difficult area to find, a very difficult area to find. And you need enough voltage to virtually break through that to find it. If you're relying on the voltage to find it and not on a visual inspection to find it. Number 5 is just a low area. If you use a carbonised rubber probe, you're going to find that the gap is increased to the total thickness, but you're not really testing that area with much more voltage. It sort of skips over the top, and if there's any raised sections, it actually lifts up. So it's not a good idea to use these rubber strip probes. The brass wire falls better into the holes, especially when a bit of pressure is put on it. This gives increased searching area. This area here has been tested with a rubber probe. The rubber probe on this sort of thing is not suitable. It skips over areas, it's lifted up. If there's any undercut with pinholes in along the welds, it will not find it. These are the areas it would most likely miss, as it just could not be tested with a rubber probe. The 2 oval circles at the top left-hand side of the photo, nothing's going to salvage those because that's stitch welded and it's not suitable for tank work. It's not suitable for any external work. Once again, these are the flaws that you would be looking at finding. It's easy to not have enough voltage or to use the wrong probe to skip over those. Generally, floors and lower sections are coated last. This can have coatings applied over dry spray dust, creating underlying porosity. This is difficult to find as it may not be visible from the surface. This is an area of underlying porosity, looking at the back side of the coating. This would be difficult to find. A further section of this showing the first coat, and this is in between 2 coats actually. Finding new flaws, pinholes when testing repairs in previously high voltage tested areas, all that can be said is you either missed them the first time and you use the wrong setting/gear, then maybe the coating has an underlying problem not visible on the surface to the naked eye. Porosity under the surface of the skin of the coating is a difficult thing to find. And with the environmental issues today, no one really needs coating failure as you need to repair. Corroded pitted steel or leaking or ruptured pipelines are a disaster. It's a different world today than what it was a few years ago. Maybe it's time to do a little rethink on this porosity detection. PCWI Porosity Holiday Detector probes, we manufacture anything you require in this area: earth leads, extensions, adapters, etc. Sales at pcwi.com.au.